In these notes, we're going to continue our work with graphing systems, but 3.5b notes will be graphing systems of inequalities, not equations. So remember, a linear inequality is where we graph a line and then shade one side or the other to represent all the possible solutions of that inequality. And so when you have a system of inequalities, which again is two or more linear inequalities, the goal here is not to find the point where these lines intersect, but to find where the two linear inequalities, the two shaded regions, overlap. Okay, so the solution here to a system of inequalities is a set of all points that make both inequalities true. So where a system of equations has one solution typically, a system of inequalities will have infinite solutions based on the shaded region that is overlapping. So let's really quickly review the rules for types of line and shading for linear inequalities. So when you have one of these symbols, you're going to use a dotted line. When your inequality symbols have the equal to bar at the bottom, you're going to use a solid line. If your linear inequality in slope-intercept form starts with y is less than or equal to, you're going to shade down. And if it starts with y is greater than or equal to, you're going to shade up above the line. Also, don't forget, if you multiply or divide by a negative, when you're solving the inequality, you need to flip the symbol. Okay, so don't forget all these rules for inequalities. They all still apply. Okay, so let's practice one. So first we're going to graph each line here, making sure we use the correct type of line, and then we'll decide where to shade. So y is greater than or equal to 2x minus 3. Let's do that. Down 3. Slope is 2, so up 2 over 1. Or down 2, left 1. And because our inequality symbol has the equal to bar on it, we're going to use a solid line. Okay. Now this symbol says greater than. So we would shade up above this red line. So just to kind of illustrate that, I'm going to highlight this area. So I guess the highlighter here is orange, but you get the idea. Now I'll use a different color for this next line. Y is greater than or equal to negative 1/2 x plus 2. So it starts up here at 2. Negative 1 over 2x, so down 1, right 2. Or up 1, left 2. It also has the equal to bar, so we're going to use a solid line. And it says greater than or equal to, so again it'll be shaded above. And so that will be this region here. Now the actual solution to the system of inequalities is where these two shaded regions overlap, which is in this section right here at the top. So what we'll want to do is actually just kind of shade in. If you were using a pencil, you would kind of shade lightly, but we can just do kind of like this. And I'm going to take out these highlighters just because we know now where the actual solution is. It's right here in the middle. So above this line, those two rules, those two areas overlap right there. And so this is the only region that we shade in. Now to pick any solution, we're just going to pick one of the points in the shaded area. So any point that falls in this region is a solution to the inequality, and including any point on a solid line in that region is part of the solution as well, because remember the solid line is used when it's or equal to, and so these are also solutions of the system. So we can just pick a random point here, say this point right here is fine, so that's 0.23. That works, but there are an infinite number of points in here. Feel free to pick any of them. Next example, we got y is less than negative 1/2 x plus 5, and y is greater than or equal to x plus 2. So the first one, y is less than negative 1/2 x plus 5. So up 5, negative 1/2, so down 1, right 2 for the slope, or up 1 and left 2. Now this does not have the equal to bar on the symbol, so we're going to use a dotted line. Okay, and it is less than, so it is being shaded down. So let's just remember shaded down on that one. Okay, next equation. Greater than or equal to x plus 2. This one starts here at 2. Slope is 1, so up 1 over 1. Or down 1, left 1. It uses a solid line. And it is greater than or equal to, so it is shaded up from that line. So we have to find the region where these two places overlap. So if you kind of imagine the shading, the first line, or the dotted line, would be shaded this way, but the second line, the solid line, is shaded up here. And so the place where those two areas overlap is right here on the left-hand side, right there. So our solution set is this region right here on the left-hand side between those two lines. Now to pick a solution, again, we're just going to pick one point that's shaded in, keeping in mind that any point on the solid line in this area is a solution, but any line on this dotted line, or any point on this dotted line, is not part of the solution, because a dotted line is not or equal to, it is just marking where the solution starts, but it is not included. So let's just pick a point. Let's go ahead and pick this one on the line, on that solid line. So negative 1, 1 is a possible solution, but really any point in this area, including this solid line, will work. Okay, next one. Our first inequality is 2y minus 4x is greater than or equal to 6. We're going to have to solve that one. Let's go ahead and do that. We're going to add 4x to both sides. So 2y is greater than or equal to 4x plus 6. Divide everything by 2. And we get y is greater than or equal to 2x plus 3. So we have this one to graph and this one. Let's do that first one. Y is greater than or equal to negative 1/3 x minus 4. Start down 4. The slope is negative 1/3, so down 1, right 3. Or up 1, left 3. And it is a solid line because it has the equal to bar on the symbol. Okay, and it is greater than or equal to, so it's going to be shaded up. Let's just remember that. Now the next line, y is greater than or equal to 2x plus 3. Same symbol, greater than or equal to, but the slope is 2. So we start at 3 and then up 2 over 1, or down 2, left 1. And it is also a solid line because it has the equal to bar on that symbol. And it is also shaded above. And so you can see where the overlap would be. This line is shaded above, so it's here. And the other line is shaded above, so it's like this. And the overlapping area is right here. This region right there. And so now we just need to pick one point in that area. Again, keeping in mind the points on these lines are okay to use because the lines are solid. Let's just pick, I don't know, this point right here. So negative 2, 2 is a possible solution of that line or that system, but any of those points will work fine. Okay, example D, y is greater than or equal to 1/2. And 3x minus 3y is greater than or equal to 12. We need to solve that second one. So let's subtract 3x. negative 3y is greater than or equal to negative 3x plus 12. Divide by negative 3, and here's where the inequality rule comes into play. Since we're dividing by a negative, the symbol flips. So y is less than or equal to positive 1x minus 4. So we'll need to graph this and this one here. That first one, y is greater than or equal to 1/2 x, has an intercept of 0. So it starts at the origin and goes up 1 over 2, or down 1 left 2. And it is a solid line because it has the equal to bar there. So there we go. And it is greater than or equal to, so it'll be shaded up above the line. So basically we know that our end result, our shaded region, will be somewhere above this line. It'll be one of these spaces up here. Now that's going to get cut into two pieces by this next line we graph, so we'll see what happens. Y is less than or equal to x minus 4, starts at negative 4. We're going to go up 1 over 1. And it is a solid line less than or equal to, and it's shaded down. Now here's an interesting thing. You can see that on this graph, these regions don't overlap, because I want this one to be shaded down here and this one to be shaded up here. But we also can see these lines are not parallel. So let's go ahead and just continue them on. If I continue these lines on this way and this way, now we can probably graph them appropriately. This one is shaded up and this one is shaded down. So our shaded region is actually in this region up here. So even though on this coordinate plane these two lines did not intersect, we could see that they would eventually. And so we end up with a shaded region that is off the graph, but we can still work with that. We do need to pick a point, though, a possible solution. So we can try to do this just to estimate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's go 11 just to be safe. One more, 11. And then we know it's 1, 2, 3, 4, 5, 6. Like 1, 2, 3, 4, 5. 11, 6 will probably be in there. So let's use that 11, 6 right here. And this is estimating, but it's probably pretty safe. So we can use the point 11, 6. The point is, be careful when you are naming a solution, because even though based on our picture we didn't have this part on the graph, but based on this picture it kind of looks like these lines don't intersect, but they would eventually, and we can eventually see where these two inequalities would overlap. Okay, example E. Y is greater than 3x minus 2 and y is less than 4. So that first one, greater than 3x minus 2, start at negative 2. Going to go up 3 over 1, down 3 left 1. It is a dotted line because it doesn't have the equal to bar. And because it's greater than, we're going to be shading above. So again, somewhere here will be our shaded region over on this side. Sometimes it can help to visualize that after the first line. Just know it's somewhere here, and this zone is going to get cut in half by the next line, and so we can kind of see where to shade in that way. The next line is y is less than 4. It's a horizontal line, again dotted because it doesn't have the equal to bar, so we know it's right here, dotted line through 4 on the y-axis. It is less than, so shaded down below that line. And so we can see that of these choices on the left-hand side, based on the first equation, it was going to be here. We can see that the overlap is just in this section right here. Down from the horizontal line, but up from the diagonal line. And then to pick a point somewhere in here, let's just use this one, 0, 0. The origin is in that region, so why not use it? But remember, these points on the dotted line are not part of the solution, and neither are these points on this dotted line. So they have to be in the region because the lines are dotted. Okay, last example. X is greater than or equal to -2, and y is less than -1/2 x plus 4. Let's do the x is greater than or equal to -2 first. Solid line, because of the equal to bar, and through -2 on the x-axis. Remember, these are vertical lines that start with x, so vertical through -2. Now it says greater than or equal to. Normally we think of this as up or down, but because x is a vertical line, we can't go up or down, so we have to go left or right, and x gets bigger as you move to the right. So this region right here would be shaded for this inequality. Now this is going to get, again, sliced in half by this next equation, or inequality, so we'll see what happens to it. So y is less than -1/2 x plus 4. So start at 4, then we'll go down 1 over 2 for the slope, -1/2, or up and left, just like that. We're going to use a dotted line because it doesn't have the equal to bar on the symbol. So dotted line there. And it is shaded down, less than, from that line. So you can see, because we were going to look at this zone here based on the first inequality, the first line, we're narrowing that to just below this diagonal line. So right here is our shaded region for the solution set, and we can pick a point in there. I used 0, 0 last time, so let's just pick maybe this one, 5, -2. That's fine, but any point here and on this solid line would be appropriate for that line, for that solution. So there you have it. Graph both lines on the same coordinate plane. Make sure you use the correct type of line, like dotted or solid, and then look at where the overlapping areas, where the shaded areas will overlap, and that is where your solution point should lie. And just keep in mind, all of these shaded points are solutions to the inequality, the set of inequalities, but for the classwork and for these notes, we just picked any solution in that set to write down.